Hello everyone, welcome to my course Istio Service Mesh Masterclass with Kubernetes in 2020. So here are 5 reasons why you should take this course. Number 1, instructed by a Cloud DevOps engineer with a k8s certified Kubernetes administrator and also certified AWS DevOps Pro working at a US company in San Francisco. So I have been pretty hands-on with the Istio Service Mesh, Kubernetes, AWS k8s with 6.5 years of industry experience in both North America and Europe. Second reason is abstract Istio concepts explained with diagrams. Istio is pretty complex and its operational complexities are pretty high. That means our learning curve is also high as well. Especially with Istio, its documentation page offers little to no diagrams explaining relationships between gateway, virtual service, destination rule, service entry, and whatnot. Because of that, I decided to provide many diagrams in this course, and this is one of them, where you can see relationships between custom Istio resources such as Ingress Gateway Service, Gateway, Virtual Service, and a Service, and how traffic flows from the internet to inside the load balancer, Istio Ingress Gateway, in a pod, Virtual Service, and Kubernetes Service and Kubernetes Pod. I created a whole bunch of diagrams from high-level architecture to low-level YAML resources for Istio features such as canary loadout, traffic splitting, JOT authentication and authorization, and much more. You will have the most visual-oriented learning experience you will ever find on the internet for Istio. So here's one of the diagrams. This is for canary rollout and traffic shifting, where you're gonna use virtual service and also destination rule to define subsets, and a virtual service to define weight, in this case 10% and 90%. And this is another diagram for another feature called JOT authentication and authorization, or we're gonna be using custom resource called request authentication and authorization policy YAMLs, and then we're gonna define a policies here so that request without authorization bearer token here in the HTTP header is gonna be rejected, and the HTTP 401 unauthorized response code is gonna be returned to users. Third reason is updated knowledge about Istio Service Mesh for version 1.5 and after in 2020. Some of the Istio architecture and components are already outdated, so I will demonstrate 2020 updated version of resources and concepts of Istio Service Mesh. This is another diagram where right hand side is about Istio enabled architecture, whereas the left hand side is traditional Ingress controller and Ingress resource YAML file. So on the right hand side, you're gonna see Istio Gateway and also virtual service here, and also you're gonna find Istio D pod. This one consists of multiple control plane components like Pilot, Citadel, and Galley. And this architectural change happened after version 1.5, and this control plane components of Istio is going to make sure that configuration is propagated to all the Envoy sidecar proxies deployed in workloads. Fourth reason is tons of hands-ons. So I'm not gonna bore you with the dry lectures, instead every concepts are paired with hands-on demo. Number 5, entire course under 5 hours. So I'm gonna cover a lot of features in this course, but I try to make this course compact and concise so students can learn the concepts and hands-on skills in the shortest amount of time. Because I know as I'm already a software engineer, life of software engineer already pretty busy, so I hope this course is gonna help you acquire Istio Service Mesh skills with the shortest amount of time possible. Next, I'm going to explain my background, education, and career experience. So, I have been a cloud DevOps software engineer with total of 6.5 plus years in software industry. I obtained a Bachelor of Science in Computing Science from Canadian University. I have worked with Java, C#, C++, Bash, Python, JavaScript, Terraform, IAC. My career started in Canada, and I also did 2 internships while in school, BlackBerry and Microsoft. And I started off as a backend software developer. So I have worked on object-oriented programming languages like Java, C#, C++. I also did an Android app application as well. And then I switched to hybrid backend and also DevOps software engineer role. This is where I started learning about CI/CD pipeline like TeamCity or Docker, Bash scripting, Python scripting, and also I started picking up Kubernetes and OpenShift. These are container orchestration tools. After that, I moved to Germany for a job and I started becoming a full-on DevOps software engineer. So here I started learning and practicing Terraform, CloudFormation to set up AWS infrastructure. Also, I was doing a scripting, so Bash, Packer, Ansible to create immutable infrastructure, meaning I was creating, let's say, AWS EC2's AMI, Amazon machine image using Packer and Ansible. And also, I was doing a Jenkins pipeline as well. And currently, I'm working at a US company in San Francisco as cloud DevOps engineer. So what I do on a day-to-day basis is using Terraform to set up all the AWS infrastructures, including AWS EKS. And within EKS cluster, I'm responsible for configuring and administrating Kubernetes objects. Also, I have worked on Istio Service Mesh. I have applied Istio Service Mesh inside EKS cluster. And also, I'm using Helm chart to deploy actual application to EKS cluster. Aside from that, I'm also using Jenkins, Dockerize Jenkins inside the EKS cluster using a Jenkins file. This was a little bit complicated process, so I'm going to create a new course just for Jenkins in Kubernetes cluster, as well as Istio Service Mesh in Kubernetes cluster in the future. Lastly, I have AWS DevOps Professional certification and also Certified Kubernetes Administrator, aka CKA certification. Okay, so chapter 1, this is an introduction to Istio Service Mesh. Okay, so what is a service mesh? So Istio Service Mesh is a network connectivity, i.e. mesh, within Kubernetes cluster created by Envoy proxy. This Envoy is created by a company called Lyft, and this is a container. So Envoy proxy container living either a standalone or a sidecar proxy. So here are two diagrams I want you to take a look at. So left-hand side is a traditional Kubernetes with ingress controller and an ingress resource. So here we have using an Nginx ingress controller service and actual Nginx ingress controller pod. And here we create an ingress resource where we define layer 7 HTTP path and then whatnot and backend services. And here, these are in worker nodes. And this is also in a worker node as well, but in a different namespace. So it could be like Nginx ingress controller namespace. And let's say this could be a default namespace, right? And then here, let's say we deploy some application called a guestbook. So we have a guestbook service. This does a layer for load balancing. And in backend, we have a pod, guestbook pod. And then there could be another services and pods as well. So this is a traditional ingress controller approach. Whereas the right-hand side, we see Istio virtual service, which is this one, replacing original ingress resource file with a virtual service. This is a specific object or resource provided by Istio. And also we see Istio ingress gateway. This is a service, and also Istio ingress gateway pod. So this is exactly pretty much the same pattern where Nginx ingress controller is replaced by ingress gateway. And inside this pod, if you take a look at this one, like an enlarged view of this one, inside this pod, there's an Envoy proxy. And this is where we call it standalone, meaning that there's only one Envoy proxy container inside a pod. That's why it's called a standalone. Whereas there's another case where Envoy proxy container can be a sidecar. This is where we see guestbook pod, and inside this pod enlarged view, we have a guestbook container as well as Envoy sidecar proxy. Because this Envoy is inside a pod with another application container, this is called a sidecar. And usually, sidecar proxies are in application workloads like this one. Whereas a standalone Envoy proxy is usually just either in an Istio ingress gateway or Istio ingress gateway pod, which is living on the edge of the service mesh, meaning that it is usually the entry and exit point of an Istio service mesh. In this case, it could be a load balancer, it could be egress gateway. So this is how Envoy proxies can be deployed in Kubernetes cluster. All right, so another huge benefit of Istio is that it comes with in-cluster default mutual TLS by default. So without Istio, let's say using ingress gateway, this is the diagram where we have internet gateway inside AWS VPC, and this is the internet, so this is the outside VPC. So inside VPC, the traffic is going to go through internet gateway and also classic load balancer by default. If you create a Nginx ingress controller service of load balancer, this is going to create a AWS classic load balancer if you're using AWS EKS. If you're using GCP GKE or you're using this Kubernetes in a local host, then this is not the case. But let's say if you're using AWS, classic load balancer, service, and actual Nginx pod. And after that, behind this ingress pod, there's going to be a service. So if you are not using Istio, say using ingress controller, then you can configure TLS termination at ingress controller pod, like here, this part, right? So initially, like traditionally, if you're using ingress controller, then ingress controller's service of type load balancer is going to create a classic load balancer in front of it. If you're using AWS EKS, then you can configure SSL termination at this level here using Kubernetes service YAML file. But if you're using Istio, then connections among backend pods in a cluster behind what used to be ingress controller, which is now replaced by Istio gateway, can be auto mutual TLS enabled without changing application code. So what I'm talking about here is connection among pods, which we are talking about these guys here. So these are backend pods, let's say product page, reviews, hypothetical names of pods here. These pods can interact with each other through services, right? So here you see dotted lines here to reviews service, and the reviews service is going to do layer 4 load balancing to backend reviews pods. So this connection, as you can see in a yellow SSL icon, this connection can be mutually TLS'd by default without changing code inside this product page or reviews to provide a certificate and also do SSL handshake and whatnot. So these are all handled by Istio. So a lot of overhead are taken care by just installing Istio. So this is a great thing because you can do SSL termination here as previously demonstrated using a native ingress controller. This could be secure, right? But without using Istio, anything behind this ingress gateway or ingress controller cannot be TLS enabled unless you change application code. So this is one of the biggest benefits of using Istio. Alright, so section 1.2, we're going to talk about Istio service mesh architecture, because we haven't talked about how Istio is dealing with configurations and administrating all the application pods and whatnot. So we're going to take a look at the architecture diagram here. So left hand side here is a traditional ingress controller approach. We've already talked about ingress controller service, ingress controller pod, and an ingress resource YAML file, and a backend service, and a pod. This is a traditional Kubernetes cluster, right? On the other hand, right-hand side, using Istio gateway here, we already talked about this is a standalone one because Envoy proxy is the only one inside this pod. So it's a standalone sitting on the edge of Istio side service mesh. And we replaced ingress resource YAML file with Istio virtual service YAML. We're going to talk a lot more about virtual service in coming chapters, so don't worry. But what I want you to take a look at here is a pod called Istio D. This is kind of like a master component of Istio. There are a control plane and also data plane in Istio service mesh architecture. And this Istio D, if you take a closer look inside this pod, there are multiple containers like Pilot, Citadel, Galley. These serve different responsibilities. For example, securities, making sure to apply configurations to individual sidecar envoy proxies from here. Pilot does that. This one is responsible for TLS cert. And I'm going to mention this a bit in a coming section as well. But these components used to be individual pods. But after Istio version 1.5 and then after, they decided to bring back this microservice architecture of individual containers back into a monolith of just one Istio D. So in this way, deployment and configuration can be much more simplified, as you can find this kind of information on Istio blog. But this is what it is right now after 1.5 and 1.6. There's only single pod that'll contain all the other control plane components like a Pilot and a Citadel and whatnot. And this Istio D is going to make sure that YAML files configuration is propagated to sidecar Istio envoy proxies living inside application pods like this one, and all the pods inside a namespace where Istio is enabled. So this is a kind of like 10,000 foot view of Istio architecture. Okay, so this is another diagram of a representation of Istio architecture. As I mentioned, there's a control plane component and also data plane component. Control plane right now 1.5 and after, there's only one single pod called Istio D. And inside, there are multiple containers here with different responsibilities. And these guys are making sure to to push configurations and certificates and do like a service discovery inside a mesh. And this is the actual Envoy proxy sidecar one sitting inside a application pod. So consider this is a pod and this is an application container like service A, and right next to it there's an Envoy proxy. So there are two containers inside this pod, and this is where it does intercept traffic. So it used to be without Istio, or without, like, if you are not enabling Istio in a cluster, service A could talk to service B directly. But after enabling Istio service mesh, then proxy is going to talk to a proxy first, and then proxy is going to pass on the traffic to service B. And if service B wants to reach A, instead of going directly to service A, it goes through proxy, and proxy to proxy, and then proxy to service A. So all the traffic between or among a Istio enabled namespaces workloads like pods are intercepted by proxy, and this is where you can enable a lot of traffic management and security features. So we're going to cover a lot of features in the next section, but this is how traffic is flowing. And here are textual explanations of this architecture. So service mesh implementations come with a control plane, which is a Istio right now, and also data plane. And data plane could be a standalone edge Envoy proxy or sidecar Envoy proxies. And data plane is composed of a set of intelligent proxies, which is implemented by Envoy, deployed as a sidecars usually. And these proxies mediate and control all the network communications between microservices. They also collect and report telemetry on all the mesh traffic. So what this proxy does is it will also collect metrics, and it will show us about tracing information, for example, like latencies or HTTP code and whatnot. And finally, control plane lives outside the request path and is used to administer and control behavior of data plane. So this data plane is where a lot of heavy lifting is done. A control plane, the master component, is where configuration and administration happens. Okay, and here are a data plane and a control plane bullet point style summary. So this is a little bit about repeating going on, but here, Envoy proxy, high performance proxy developed in C++ to mediate all inbound and outbound traffic for all the services in a service mesh. Envoy proxies are the only Istio components that interact with the data plane traffic. And there are multiple features here: traffic control, network resiliency, security, and authentication and authorization. So traffic control, there are a few of them that I want to mention, but all the features are going to be actually covered in the coming chapters. But there are different kind of load balancing policies, for example, round robin, random, or least connection based load balancing policies. Also, you can set weight based traffic splitting, like it's called a canary release. You can set 20% goes to this backend service version 1 and 80% goes to version 2 and whatnot. Also, so these are Istio specific new resources: virtual services, destination rules, gateways, service entries, and sidecar is not actually a resource, so forget about this one. And in terms of a network resiliency, there are a few features provided by Istio. Fault injection, this can be injecting HTTP error code or delay, retries, circuit breakers, failover, and health check. In terms of security and authentication, it does TLS termination as well as JOT. JOT means JSON Web Token authentication and authorization using a HTTP header. So this is pretty cool stuff. And in terms of control plane, as I mentioned, Istio-D is aggregation of a Pilot, Galley, and Citadel. And there are a few things that they do. Pilot is the data plane config server. So this is making sure that configurations are propagated to sidecar Envoy proxies. Galley, configuration watching, validation, and forwarding. Citadel, certificate signing, secret generation, integration with CAs and whatnot. So I've already mentioned that Istio provides you a default mutual TLS certification, right? Mutual TLS. So A and B, like a pod. Think about this as a pod, A and B. Connection here is secured by mutual TLS, which means it's kind of like a TLS but mutual. And so there needs to be certificate authorities and also server certificate and a client certificate. So these are provided and also maintained and administered by this component. You don't need to really change anything because these are provided by default. Next, section 1.3, I want to mention architecture change from before and after version 1.5. So I've already mentioned that before and after version 1.5, these Pilot Citadel telemetry policy components, which are part of the control plane, got aggregated into one pod called Istio-D. But before 1.5, they existed as an individual container in a pod. So this is kind of like a microservice architecture. Only thing that changed after 1.5 is everything is inside Istio-D. So it went back to a monolith approach. Istio blog talked about the reason behind going back to monolith, and sometimes microservice doesn't make sense, and in this case, going back to monolith and then pushing everything inside one pod and simplified and also reduce the complexity of installations and maintenance. So reduce the installation and configuration complexity by moving control plane components into a single component called Istio-D. This binary includes the features of Pilot, Citadel, Galley, and the sidecar injector. So this is kind of like microservices turned back into a monolith in favor of easier management. So this is something that I wanted to mention because if you look up online about Istio blog, there are a lot of blogs or articles based on Istio 1.3, 4, and this 1.5 and 1.6. So section 1.4, why Istio? So I've already explained about what is service mesh and Istio service mesh architecture, but I wanted to kind of stress why you should be using Istio. So I'm going to be explaining some of the features that are provided by Istio, so you know what kind of benefits you're getting by start using Istio. And I'm gonna use a lot of diagrams so that for you visual learners you can get gist of ideas and concepts, because when I look at Istio website and documentation pages, there are a little to no diagrams, and it was really hard for me to understand what they really meant and also what they meant in terms of architectures. So I decided to use a lot of diagrams for visual explanations. Service mesh requirements can be thought of as a typical API gateway functionality. But instead of having just one API gateway at the edge of the network, consider each sidecar envoy proxies acting as API gateway. So what this means is like if you have a network like a load balancer, like a proxy, and then these are backend services, this could be API gateway, right? And API gateway can provide, if you don't have a API gateway, it can provide load balancing features as well as like circuit breaker, rate limiting, cores, and a lot of different stuff. They can probably do canary release as well. But this is kind of like having a Spock, right? One to many relationship, right? This is one, and this is like a many relationship. Whereas with Istio, or in general terms, service mesh, you can have multiple backend services, right? And they can talk to each other. And so combinations and permutations could be very large. In this case, there are 4 backend ports. So total combinations of network, including a direction, is 4 factorial, which is 4 times 3 times 2 times 1, which is 24. So there are 24 different ways of communicating if you include a different direction, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So sorry, 4 factorial, it's not 4 factorial, it's not permutation. 4 factorial divided by 2, so it's a 12, right? So how do you manage each traffic connections? And you can provide API gateway kind of feature into each combinations here by providing sidecar envoy proxies. So this is how I think about service mesh. Okay, so one of the benefits, I'm gonna list through a lot of features and benefits here. So under traffic management, there's a control ingress traffic using gateway, virtual service, and destination rules. So these are Istio specific resources, and this could be confusing, so I'm gonna explain. Gateway is really kind of like replacing ingress controller, these two. It used to be ingress controller implementation without Istio. So this part is now called a gateway, and gateway YAML file is here. This is an example of it, and this is a service. And this service is type of load balancer in AWS k8s. So if you're using AWS k8s, then type of service load balancer is going to create by default classic load balancer, and this is a service, and this is the gateway. And gateway references this service by a label Istio ingress gateway. And what is virtual service? Virtual service is this one. This was traditionally ingress resource YAML file. This is where layer 7 load balancing configuration were stored and configured here. So basically you have like HTTP route destination backend host is guestbook. And what is guestbook? This is registered in a service registry in an Istio service registry. And guestbook refers to guestbook.default service cluster local. If you know about Kubernetes, this is a fully codified domain name of a service. So this is a name of the service, and this is a namespace default. So guestbook inside a default namespace, and this is the type of object, which is a service, and a cluster local, which is happen to be this one. So this is the service. So here the relationship doesn't really change. This used to be ingress resource YAML file, and the ingress resource YAML file usually refers to a backend service name like here, and this refers to this guy, service of guestbook in a default namespace. And this is a Kubernetes native object, so you already know service defines backend ports, protocol, and a target port. This goes to the actual port, right? And a selector and a type node port. A little small difference though between ingress controller implementation and also Istio is that when you're using ingress controller, backend service type should be node port. It cannot be cluster IP type. Whereas in Istio, virtual service can refer to a service even if service is of type cluster IP. So this is a little small difference, but it doesn't really affect you because Istio can work with either node port or cluster IP service in the backend. So this is how traffic is handled in a diagram in a linear way. Ingress controller and ingress YAML file were replaced by gateway and also virtual service. We're going to talk a lot more about this anatomy of gateway and virtual service YAML files in next chapter. Okay, so next feature benefits is a load balancing. So if you look at this diagram, we've already talked about how these parts are Istio specific new resources, gateway, and also virtual service. And behind the virtual service, there's another resource that you can create called a destination rule between virtual service and the backend Kubernetes service. So between these 2 points, there could be another object called a destination rule where you can configure a backend services load balancing policy. So here, from service to a backend pod, by default, it'll do layer 4 load balancing with a round-robin algorithm. That's a by default in Kubernetes. But if you want to control and customize load balancing algorithm and policy, you can do so. So here, this is defining, just an example though, this is the global load balancing rule set to be round robin, whereas you can define a new like a map key value pair called subsets. This is also an Istio specific one. You can define subsets, which is just named versions of different deployments and pods. So let's say we have a list of a name and we have V1. This is saying they are creating a subset called a V1, and a version V1, this is a label. And this happens to be a label attached to these pods, 2 pods labeled as version V1. So for these pods, they want to control load balancing policy to be least connection here. So from here, you see a dotted arrow here. So load balancing algorithm so reviews V1, 2 pods, are going to be least connection. Whereas other pods by global configuration here, it'll be round robin load balancing. So you can configure stuff like this if you want to. So Istio is going to provide you a much more fine-grained, more complete control over traffic and network inside the Kubernetes cluster. Next feature is a service entry. Service entry is really about registering external DNS to a Istio service registry and service discovery. By default, all the Kubernetes clusters services are added to Istio service registry. But if your application wants to reach external website, let's say like a google.com or AWS, then Istio doesn't know about it. If you want to keep track and also control the traffic going to those external DNS, you can register those external DNS into a Istio service registry using a service entry resource. And in that way, you can monitor traffic to that one, and also you can control traffic onto that external DNS using like TLS or using a timeout and whatnot. Next benefit, we're gonna talk about request routing. So this is a fine-grained control of traffic behavior with rich routing rules, retries, failovers, and also fault injection. And one of them is TLS termination. So this is also possible with ingress controller service, but with the gateway, you can also do that as well. So this used to be ingress controller, and you used to do that like TLS termination by providing annotations and whatnot in service YAML file. Whereas here, you provide in gateway YAML file, you create this TLS block and you select the mode simple and a credential name. This references secret name where it contains a TLS certificate. So if you provide this one, then you can terminate HTTP traffic this point. So here. Next, I'm going to talk about canary rollouts. So canary is like you have like two or multiple endpoints at backend, and we want to say weight-based routing. So let's say 20% goes to this A and 80% goes to B. In that way, you can ensure that newly released application receive a portion of traffic, and you can test new version of application with a small amount of traffic without erroring out a lot of live traffic. So here we have ingress gateway, service and pod, and a virtual service. This is where layer 7 load balancing happens. So HTTP, backend V1 and V2. And here you see weight 10, weight 90. So V1 receives 10% of traffic, and then V2 receives 90% of traffic. And this V1 and V2, these are created by subset. And remember I mentioned briefly about subsets created by destination rule object. So here destination rule, it defines two different names of subsets, V1 and V2. And this is the labels attached to pod V1 version V2. And this version V1 label goes to this labels attached to reviews V1 pod. So this references labels, whereas this name V1 and this name V2 are actually named subset. And here it's saying 10% 90%. So 10% goes to destination rule subset V1, 90% goes to this one, and it goes through service. And service is gonna do load balancing with like a canary. So 10% goes to V1, 90% goes to V2. So this is a really cool feature provided by Istio. You can do more confident approach of rolling out new features of applications. Next, another benefit is identity or header-based routing. So in this virtual service object, you can have a match list defined, and this is basically looking at the condition in a header. So match headers, end user, exact tester. This is really saying that if end user equal tester is found in HTTP header, let's say here, given that tester is making an HTTP request, and inside a header, there is a key value pair called end user tester. If this condition matches, then provide a route to a V1 of reviews. Review V1, V1 is this one. So if end user is a tester, then go through here, and the virtual service is going to make sure that request is routed to V1 here, as opposed to V2. So this is a kind of a cool way to route traffics, like let's say test traffic to a certain specific versions so that production users won't use that testing applications. Another one is a failure recovery. It comes with like multiple flavors. So delay, abort, retries, and a timeout. So for example, you can add delay, 10-second delay here by defining a virtual service in a fault, delay, percentage 100% of traffic with fixed delay for 10 seconds. You can customize the delay. This is so that you can test how application behaves if some of the backend applications not responding for like certain amount of time. So they're like dependencies of a backend services, right? Like a microservice architecture and with a service mesh. So if one service fails or takes a long time to respond, you want to see how other services are going to respond and behave, because you don't want one service to fail or take a long time and all other services to hang up. You don't want that kind of cascading effect. So you basically want to set a timer for some of the dependent services so that it doesn't wait indefinitely. So this is by injecting manual delay or latency, you can see actual behaviors of multiple components backend. Another thing is called abort. This is where you can inject HTTP error code. So here you see fault, abort, 100% of traffic. It's going to return HTTP status of 400. So you can do that, and you can force this virtual service to return HTTP 400. And again, you can use this to really see other components' behavior. Another one is called a timeout. So let's say we have defined a fixed delay of 10 seconds, and also we define timeout of 1 second. So what's going to happen is that request is made, and this is going to take 10 seconds, but virtual service is going to only wait for maximum 1 second and a timeout, and it returns an error code or something like that. Another one is retries. So you define retries attempt 3 per retry timeout to be 3 seconds and retry on 5xx. So reset, you can select a lot of different stuff for retry on conditions. And in this example, request is made and still there's a 10 seconds delay. And because this one is going to wait for 3 seconds, after 3 seconds it will retry maximum 3 times. You see 3 red arrows here, 3 retries, and each retry times out in 3 seconds. And after 3 times in consecutive errors, it will eventually return an error code. So you can configure this behavior as well. Next feature is mirror live traffic. So this is a feature where a live traffic, let's say this blue line, goes to a reviews v2. However, with the virtual service mirror section here, you're specifying host reviews subset v1 and a mirror percent 100%, meaning that 100% of traffic to version 2 will be mirrored to subset v1. So this red line is gonna be copied to version 1. This is great if you want to test or release a new version and if you want a portion of live traffic going to a new application version. Another features including rate limiting, circuit breaker, also controlling egress traffic as well. Next, we're going to talk about security aspects of benefits. So Istio is going to transparently secure traffic behind the firewall. So it'll do automatic mutual TLS among backend services. So if you look at these icons, like a yellow SSL icons, these are the backend connections. So take a look at this product page pod. This is going to connect to a reviewed service, which does layer 4 load balancing to reviews pods in backend. So connection between product page and reviews are also TLS secured, mutual TLS secured, and as well as connections from Istio ingress gateway to a virtual service and virtual service to backend service to backend pods. So this is another diagram for Istio documentation page. So basically, control plane is going to make sure to provide certificate authority for TLS connection. Think about this gray rectangle as a pod, and inside this pod, there's a service A container and also envoy proxy as a sidecar container. So this envoy is going to talk to another pod's envoy with mutual TLS connection. So instead of going from service A to service B directly with the HTTP plaintext, instead connection is going to be intercepted and it's going to be started from envoy, from service A to envoy, and an envoy to envoy, and an envoy to service B. In this way, connection among pods in the backend are going to be mutual TLS enabled. Another security feature is end-to-end authentication and authorization using JWT. JWT stands for JSON Web Token. It's kind of like a password, but it's a little bit more secure. So take a look at this diagram. Here we see ingress gateway YAML file and also another new resource called request authentication and also authorization policy. This request authentication can specify a JWT link where a JWT token is provided. And with this one, you can say, hey, at this ingress gateway level, we want to authenticate requests from users. So let's say unauthorized user is going to make a HTTP request to a https://bookinfo.com without any information in a HTTP header. So this request goes to Istio ingress gateway here, and because of this authorization policy, which states that it should deny any request without request principals. This request principle should exist in the HTTP header if there is a authorization bearer token, which is for JSON Web Token. So this means if JSON Web Token is not provided in a HTTP header, then you should deny. So because of this authorization policy, this ingress gateway is going to return 401 unauthorized HTTP error code back to this unauthorized user because this HTTP header doesn't include a bearer token. Was this authorized user case, HTTP header includes authorization bearer with this JSON Web Token. So this HTTP request with a JSON Web Token included in the HTTP header is going to be able to authenticate and get authorized here, and it can go through ingress gateway and then it can reach backend services. So this is another thing, authentication and authorization using JWT. This is another feature of Istio. Okay, so moving on to observability aspect of Istio. So you can debug the latency in this architecture using this kind of diagram. This is a Kiali dashboard. This is the part of Istio installation if you're using a demo profile. We're going to cover this in next chapter for Istio installation. But with this, you can visualize about metrics, logs, and traces for all traffic within a cluster, including cluster ingress and also egress. So take a look here. This is a Istio ingress gateway. And this is a service and also a pod. And from here, in the backend, we have a product page virtual service. The purple one is a virtual service. And then this V1 is actual pod providing a product page application. And also there's a detailed service, the view virtual service, and the review pod, rating virtual service, and rating pod. So you can see these edges, green ones. You see this lock icon. This means mutual TLS is enabled among a connection between these two components. And also you can see a lot of different informations like this one. In this case, you can see a 4.88 seconds. This is a latency. So this is how much time it's taking to reach this service. This is a 5 milliseconds. So you can see about latency, metrics. Also, you can see logs and tracing. And then what's cool about this one is you can see topology of microservices, meaning that you can see traffic flow going this way, and going this way. And if you see some like HTTP error code, if you take a look at this dashboard, you will know which edge is failing. And therefore, you can use that information for debugging. So in the second chapter, we are going to set up EKS 1.16 cluster with EKS CTL in 15 minutes. I wanted to premise this chapter with this note. So even if this course touts 0 to hero AWS EKS hands-on production best practices in 2020, for illustration purpose, we will be using EKS CTL to spin up AWS VPC and EKS cluster in one command. In production though, you should be using IAC. IAC stands for Infrastructure as a Code, such as Terraform or CloudFormation, which could require entire course for it. So I'm not going to use Terraform for this course, but eventually you should be able to spin up AWS and EKS cluster using Terraform. First section 2.1, let's create AWS IAM user, access key, and an EKS cluster IAM role from console. To do that, let's create AWS account first. So to create AWS account, you're going to follow this link, aws.amazon.com resource create-account. So I have that page open in this tab. So I'm going to click sign up now button. Here you're going to type in your email address, password, and also account name. Once you type in email and address and account name, you're going to click continue button. Here, you are asked to punch in your contact information. I'm going to select personal for this account type. Full name, phone number, country and region, address, city, state, postal code. These are required to create account. After typing in your contact information, you're going to click create account and continue button here. After clicking the button, I see that reloading icon is showing on a web page. Now you should receive this email, welcome to Amazon Web Services. And you have a link to free tier. You can click this link. And then the link takes us to this AWS free tier, create free account, and also top right corner, orange sign into the console button. So let's click this one. And this is gonna take us to login page. So now URL says sign in AWSamazon.com. So here, sign in. We have two options with the two radio buttons, root user and IAM user. Well, we're going to select root user because we haven't created any AWS IAM user within this account. So we're going to log in as a root user. So select this one and then type in your email address you use to register your AWS account. And after that, click next button. And now it's asking you a password, so you enter your password. And then click sign in. And now you should be logged in to AWS console. So that's the first step to create an AWS account. Next step is to create AWS IAM user and also assign access key and a secret access key so that you can use command line interface for AWS. So let's do that. So first, you're going to top left corner services. I hope you should already know about AWS console and AWS services because this course requires you to have basic knowledge about AWS, but I'm going to have a little bit of explanations about AWS console when I'm going to walk through this console. So from this services, you're going to type in IAM and there's going to be IAM service. So click this one and it's going to take us to IAM console. IAM stands for Identity and Access Management. This is where we can configure like a create, delete, modify AWS users, IAM roles, and IAM policies. First, we're going to create new user. So click this users on the top left corner. And here we see no user because this is a brand new account. So what we're going to do is to click this add user blue button here. And here we're going to punch in some username for new AWS IAM user. For demo purpose, I'm going to use EKS demo. And access type, I'm going to check off programmatic access. This is going to enable us to use AWS CLI. So we need to check off this option, programmatic access. AWS Management Console access. This, you might need it, you might not need it, but I recommend you to check this off because it is a security best practice to log in as a new AWS IAM user as opposed to root user, because root user has all the access, for example, like billing. In a console password, you can select auto-generated password, custom password, require password reset. I'm not going to check this off. And in terms of console password, I'm going to create a custom password for this k8s demo user. Now I have created a new password for this k8s demo user. I did not check off require password reset, checked off programmatic access, AWS Management Console access. It looks good. So click next permission button here. And here we want to attach some permissions because this user doesn't have any permission. Then this user cannot even do like S3 list or create k8s cluster. So what we're gonna do is to just assign root IAM policy for this user. What I'm going to do is to click attach existing policy directly. And here at the top, you see administrator access. If you expand this tab, you're going to see in a JSON, for example, you're gonna see effect allow action asterisk resource asterisk. What this means is that basically this user can do any actions on any resources on AWS. This is the admin access. So in production though, you shouldn't be giving administrator access to random AWS IAM user, but for demo purpose, I'm going to just select administrator access. And after that, click next tags button at the bottom right. And then tags, I'm going to omit this and then click next review. And here, you're going to review this summary of this new AWS IAM user we are going to create. Username k8s demo, access type, programmatic access and AWS Management Console access. That's correct. Console password type custom. Require password reset, no. Permissions summary, we have manage policy administrator access. This is correct. So I'm going to click create a user button here. Alright, so now new user is created, k8s demo. And what you're seeing right now is AWS access key ID and also secret access key. These are necessary for this user to use AWS command line from a terminal to do some operation against AWS. So you need to click this download.csv file and then store this one securely. Do not upload or publicize this file because this contains secret access key, which is kind of like a password. And if you have this access key ID and a secret access key, and this user has enough permissions, then anybody, even like hackers, can access your AWS account. What could happen is that you might end up getting huge amount of bills. So treat this as secure as possible. All right. So what we just did is after creating AWS new account, we also created AWS IAM user. And also along with that, we also created access key and a secret access key, which is necessary for us to be able to use AWS command line. Next, we are going to install AWS command line. If you haven't installed it, then you're going to use Brew, Homebrew, which is a package manager for Mac, or if you're using Windows, you can use Chocolate. I'm using Mac, so I can use Brew. If you haven't installed Brew, then first you need to install Brew. So to do that, you just go to docs brew sh installation page and scroll down a bit. In the middle, you see this command. You're going to copy paste this one and type it in here in the terminal, and this is going to install Homebrew on your Mac computer. So next section 2.2, we are going to install AWS command line on our terminal or computer. So just follow this link, install-command line v2, and then you open this page on the browser and you're going to follow based on your operating system. Let's say you're using Windows, and also you could be using macOS as well, right? macOS is going to be easy. I have a Brew installed, but if you haven't, then you can just copy paste this command and paste this into the terminal, and this is going to install Homebrew, which is a package manager for Mac. Alright, so now Brew is installed on my computer. What I can do is to use this command, brew install AWS command line. So you're going to copy this line, and paste this in and hit enter. This doesn't need to be run on my computer because AWS CLI is already installed, but I'm just showing you what it looks like if you run this command. Okay, so command finished. Anyways, so this is how you can install AWS CLI using Brew for macOS. If you're using Windows, just follow this AWS documentation page for Windows. So you're gonna expand this tab, install AWS CLI version 2, and then click Windows, and they're gonna take you to this page here. installing the AWS command line version 2 on Windows. You first need to download this AWS CLI MSI installer for Windows 64-bit by clicking this link. Now after that, run the downloaded MSI installer and follow the on-screen instructions. To confirm the installation, open the Start menu and search for CMD to open command prompt window, and at the command prompt, use AWS version command. So basically after you follow, whether you're using Mac or Windows, they're going to converge to this. You run AWS -- version to confirm that your AWS command line is installed, and it's going to return the AWS command line version, which is currently 2.0.8 on my computer, which is good. Next, what you're going to do is to configure your AWS command line. So to do that, you can type this AWS configure command, which is going to ask you about your access key and also secret access key. This is from my console. So remember, when you create a new user, you have this access key and a secret access key. And I hope you download this CSV file in case you forget this one, because after you close this window, you cannot see secret access key anymore. So if you want to take and also save the secret access key, only way is to click this show button or download this CSV file from this button. So what I'm going to do is to copy this AWS key ID here and then type in here, enter. Now it's asking me AWS secret access key. Currently the value is set to none. So what I'm going to do is to click this show button, which is going to reveal secret access key, and then copy, paste. And then it's asking me default region name. This is based on where you want to create EKS cluster and also based on your location as well. It's usually better to create AWS region closer to your location. In my case, I'm going to use US West 2. So I'm going to type in US West 2, enter. Default output format, I'm gonna select text. You can, for example, select a text or JSON here. So I'm going to select text, enter. Now this is configured. What you can do is to issue some AWS command, for example, AWS S3 ls. And it's gonna list out all the buckets in S3 account. But it says no sign up when calling this bucket operation. Your account is not signed up for S3 service. You must sign up before you can use S3. So let's see. If I run this command sts get caller identity to identify who I am, it says my username is EKS demo, which is good. Account number is 0816. So what this error is saying that your account is not signed up. You need to add your billing information like a credit card. So what I'm going to do is to go to AWS console, top right corner, you see a drop down, a demo. This is the account name. Under, you're going to see my billing dashboard. You click this one. Unless you log in as a root user, usually you won't be able to see. But because I have logged in as a root user, I can see this billing. You need to type in your credit card information. Otherwise, AWS cannot charge you. So from here, payment method, you need to add a card, a credit card or a bank account. So here you need to add your credit card, okay? After you typed in your credit card number, name, month, year, click continue button here. And then here, if your credit card's billing address is the same one as your address you used to create your AWS account, then you can just check off this use contact address option here. And then after, click continue. Now it says saving and it says credit card is saved. Looks like it's good. So after seeing this your account is not signed up error, I went to dashboard for billing and I make sure that I punched in my credit card information, and I went to S3 and S3 shows me unexpected error occurred. If I go to EKS cluster, type in EKS here, enter, and I go to EKS cluster console, it shows me this, your service signup is almost complete. It says it's not complete yet. And one of the options like reasons being verify your credit card information is correct. They're going to send $1 bill to your credit card, confirm that your credit card is correct. And also you need to check your email if you have received any request for additional information. And also you need to provide all the necessary information during the sign up. So let's click this complete your AWS registration link here. And here it's asking me about my identity. So it's a phone number verification. So what you can do is just type your phone number and then send SMS. Now it's going to send you SMS code. So you need to punch in the security code here and then verify code. Your identity has been verified successfully. Click continue. And now it's asking me about support plan. We're gonna go with the basic plan because we are doing demo. So click free. Confirmation. Thank you for updating your AWS subscription. Go to management console button. Now the error should be resolved at this point. So enter AWS S3 LS. Still, your account is not signed up. So it takes a while for AWS account to be ready. So wait a while if this happens to you. Next section, we are going to install AWS IAM Authenticator. This is going to be as easy as brew install AWS IAM Authenticator if you're using Mac. If you're using Windows, then you're going to use another command. Alright, so AWS IAM Authenticator is installed. If you're using Windows, you're going to use Chocolate. This is the easiest option. So make sure you install Chocolate first by following this link. And after that, just execute choco install-y AWS IAM Authenticator. So now AWS IAM Authenticator is installed. Next section, 2.4, install kubectl. So this command line is required to interact with Kubernetes cluster. So if you're using Mac, just use this brew install kubectl. Enter. If you're using Windows, then use choco install kubernetes-cli. Alright, so now kubectl is installed. To verify that command line is installed, you can issue this command kubectl version. Kubectl version. And if it's installed, then the version is returned. So it says here, a client version is 1.15. Alright, so which is good. Next section, install eksctl. eksctl is a command line to interact with AWS Elastic Kubernetes Service. So this is not Kubernetes native CLI, but this is a Kubernetes on AWS, meaning EKS. So they provided EKS specific command line tool called eksctl. So for Mac, this is also easy. Brew tap and brew install weaveworks tap eksctl. So clear this shell first and then paste in 2 lines here. First, brew tap weaveworks tap, and after that, brew install weaveworks tap eksctl. Enter. Again, if you're using Windows, then just do chocolate install-y eksctl. Alright, so after that, we can check eksctl's version by issuing eksctl version, and then now it returns 0.24.0, which is good. Lastly, before creating EKS cluster, last section is create SSH key for EKS worker nodes. This is in case where you want to SSH into EKS worker nodes from your local host for debugging purpose. So to do that, we are going to use ssh-keygen command. Alright, so if you're using Mac and Linux, this should be installed already. If you're using Windows, you should install OpenSSL command. So what I'm going to do is to issue this ssh-keygen, enter. And this is going to ask me where to store a new private key and also public key. So what I'm going to do is enter the path, like full absolute path here. So I chose this name eks-demo.pem. So under your home folder and hidden ssh.sh/eks-demo.pem and I enter. I have already eks-demo from a previous demo that I did. I'm going to override by selecting Y, enter passphrase. This is a passphrase if you want to encrypt public key and a private key. I don't need to encrypt my SSH key, so I'm gonna enter without typing anything. Enter, enter, and then now it's created. Alright, so I can check the newly created SSH key by doing ls command. ls home/.ssh eks-demo, and now I see eks-demo.pem and also pem.pub. This is a public key that I'm going to upload to a new EC2 instance, and this is a private key which we are going to use to decrypt a SSH connection. Alright, so with that said, everything is set up at this point. We've installed AWS command line, we've installed AWS IAM Authenticator, installed kubectl, this is the Kubernetes native command line, and also eksctl, this is for EKS command line tool, and create a SSH key. So last step is to use eksctl command line tool using create cluster command to create a EKS cluster. What I'm going to do is to copy this command eksctl create cluster and a whole bunch of arguments. I already have this one pasted in too long don't read commands.txt here. Now basically you can modify some of the arguments if you want to, but you don't need to. For example, I'm going to create an EKS cluster in US West 2 region. Depending on your geographical location, if you're based in East Coast, West Coast, Europe, Asia, you can change this region. And also, I'm going to use T3 medium for EC2 instance. And these three lines are configurations for auto scaling group. So what I'm doing here is I'm going to set desired number of EC2 instances to be 1 initially, and also setting the range, minimum to be 1 and the max to be 2 because I want to save money. And in here, also we are passing SSH-access argument with SSH-public-key. And then we are passing SSH public key that we just created in the previous section, just in case we want to SSH into EC2 instance. And then lastly, we are passing --managed. This is notifying EKS that we want to use EKS CTL managed worker nodes. We're going to go over what it means to be EKS CTL managed, and also we're going to explore limitations about this EKS CTL managed nodes. But for now, we are going to go ahead with this command. So copy and then paste, make sure everything is all right after changing region, and make sure this SSH key name is correct, and then enter. This is gonna take about 15 minutes, so I'll come back later. You can confirm this one by going to AWS console for EKS cluster. And you see here cluster name EKS from EKS-CTL is created, Kubernetes version is 1.16, status is active. If you click on this one, you're gonna see more details about this cluster. I'm gonna walk you through this EKS console in coming chapter. But for now, let's go back to Visual Studio Code README and just keep moving on. So these are the outputs from EKS-CTL create cluster command, and these are the ones that we see on the terminal. Let's move on to this one here. So once EKS cluster is created, we can use this command AWS EKS describe cluster and specify name as an option and a region as an option as well. And with this, you can get output of EKS cluster information. EKS describe cluster dash name, and it will return JSON output of cluster information such as name, subnet ID, security group ID, blah blah blah. This is essentially what we see on this console, but in JSON format. So see all of the subnet IDs, VPC ID, login, details. These are all stored here in JSON. Type Q to exit out, and right now we can use kubectl get service to list services in Kubernetes cluster, which should be only one right now. There's only one default Kubernetes service, which points to API server in master node, right? If I do kubectl get pod, there should be nothing. Cool. So right now we are back in business. Kubernetes cluster created, AWS IAM user created. We as an AWS IAM user, we can authenticate to Kubernetes cluster using AWS IAM Authenticator. So in the second chapter, we are going to install Istio. So first section, 2.1, we are going to install Istio using Istio-CTL. But before that, let's install Istio CLI from a website. So we're gonna first install Istio-CTL command line. So we're gonna use this curl command to download version 1.6.7. This is the most updated version of Istio CLI at the time of recording this lecture. So I'm going to paste in this command curl https istio.io download istio pipe, and we are setting environment variable called istio version and a version name 1.6.7, and we are going to hit enter. This is going to download a Istio CLI binary into current directory. Okay, so download is complete. You see Istio has been successfully downloaded into Istio 1.6.7 folder on your system. So at this point, I'm going to create this shell and I do ls command to see all the folders inside this current directory. And you see Istio 1.6.7. So next, we are going to cd into this folder. So cd Istio 1.6.7. And now we are inside this folder. So what we are going to do next is to export path variable with a bin folder inside this folder to this variable, and then we are overriding this bash profile file. This is a file that gets loaded every time you open new bash terminal. So we are going to do this so that whenever you open new bash terminal, then this path variable can load up a path to this istio binary path. So grab this command, echo export blah 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 all the way until your bash profile, enter. And then right now, this export line should be stored in bash profile. Okay, so next thing, we need to open new terminal so that this path variable can be exported. So what we're going to do is to click this one, split window icon, to create another terminal right next to existing terminal window, which is this one. So new one is the middle one, so we don't need the left one because left one's path variable is outdated. So we are going to kill terminal, and we have this one. So this terminal has most updated values of the path variable. So if you do istio ctl, and this is gonna return help. So that means this worked. So I'm going to kill the right window as well and recreate that new terminal here. So right now, every time new terminal is loaded up, that line, export path line in a bash profile that we just saved, is gonna load up. So on the right hand side, istio ctl, and this will work as well. Okay, now istio CLI is already installed and configured properly. Next, we are going to install Istio inside the Kubernetes cluster using Istio config profile. Okay, so next section, we are going to install Istio to Kubernetes cluster using Istio config profile. So there are few preset profiles that we can install using these named profiles. So here's a table, a default, demo, minimal, and remote, and etc. So what we're going to do is to use this demo profile because demo profile comes with the most amount of components pre-installed if we use this one. So for example, in this table, you can see with the demo, we can have Istio egress gateway, ingress gateway, Istio-D, this is the master control plane component, and also add-ons, for example, monitoring tools like Grafana, Istio tracing, this is a Yaga, k8s, this is a request tracing topology related dashboard, and a Prometheus. So Prometheus is also related to Grafana. So if you install Istio using demo profile, then these are coming with it. Whereas if you use like a default or minimal, then you don't get to see a k8s or Istio tracing or Grafana. So we're gonna use a demo profile, which comes with, I've already said, but ingress egress gateways as well as Grafana, k8s, Yaga, this is a request tracing, and also Prometheus monitoring and metrics dashboard. So to do that, we can first display the list of available profiles using Istio CTL profile list. So let's do that. So we're gonna expand this terminal a little bit here and clear. What we're gonna do, Istio CTL profile list, and it's gonna list out about 6 profiles. And you can also see actual configuration files for each profile. So here we can say we want to save this config file of a profile demo into this YAML file. So Istio CTL profile dump, and then name the profile, in this case demo. Then we can even print out all the configuration files here. So this contains configuration for egress, ingress, and Grafana and whatnot. So what we're gonna do is to save this one in a YAML file. So to do that, first get out this Istio 1.6.7 folder. So go back to previous directory and then list out all the folders inside this current folder, and then you see a to install folder. So let's go to cd to install ls, clear, and then ls again, and you see that there's no files, like no YAML files. So what we're gonna do is to do this and save this YAML file into profile demo config.yaml, so we can take a look at YAML content. So right now we have profile demo config saved under second folder, and this is the YAML file for profile demo. So you see profile demo at the line 158 tag, this is a version number, and if you scroll up to the top, you see kind Istio operator. Under add-on components map, you see a list of a bunch of stuff that I mentioned before: Grafana, k8s, Prometheus, tracing, this is Yaga. And in terms of component wise, this is a Istio related component. So you see Citadel, CNI, egress gateways, ingress gateways as well. And here under Kubernetes k8s, this is the map, and this Anything under this Kubernetes map is compatible with Kubernetes native objects YAML file. So you see like resources, request, service, ports, and blah blah blah. These are service and pod configuration. You scroll down, you see pilot, policy, and a whole bunch of stuff. But what we're gonna essentially do is to install Istio using this configuration. But we can do that by simply referring to profile name called demo. Alright? So before actually installing profile demo, we can also generate manifest YAML file for profile demo. So this is gonna print out actual Kubernetes objects like service and deployment YAML files. Whereas a profile demo YAML file that we just saved, this is not entirely Kubernetes objects. Some of the components configured here are related to Istio, and only Istio can understand. So not necessarily all the kinds of resources here defined are not Kubernetes objects. Whereas if we are going to use a Istio CTL manifest generate with a profile demo, we are going to list out all the Kubernetes objects that are going to be created. So let's do that. So from here, grab entire command, paste in here Istio CTL manifest generate profile demo, and save it under generated manifest demo.yaml file, hit enter. And this is going to save into a new file called a generate manifest. And inside here, everything here, all the resources and objects are Kubernetes objects. So you see here config map is one of the kind. And if you scroll down, this is like a huge file. So if you scroll down to the last one, you see the line 20,000. So it is almost impossible to go through all the resources defined in this YAML file. But basically, I'm telling you that all the files here are going to be converted from this profile config. So this is a Istio related profile configuration. And then after converting all the configuration into Kubernetes object YAML file, it ends up being like this config file. So what we're going to do is to next section, we are going to install Istio. So to do that, we are going to use istioctl install -- set profile demo. This is a simplified version. So there's a note here says that istioctl manifest apply works for both 1.5 and 1.6, but this, when we're installing, will be deprecated from version 1.7 in favor of istioctl install, which is the second one here. The reason why I showed you how to generate manifest YAML file is because in the same way you have istioctl manifest generate, whereas this one is istioctl manifest apply. This is going to be deprecated. So instead of using this kind of like a long YAML file configuration, we can just use istioctl install command as opposed to manifest apply because it's going to be deprecated. So what we're going to do is paste in this istioctl install -- set profile equal demo and enter. Alright, so this is going to install and deploy all the Kubernetes resources and objects that are defined in this generate manifest YAML file. So this is a lot of objects here. You see here, this is a tiller component install mixer. Custom resource definition is a kind. And you also have custom resource definition. This is for Istio pilot. So it's doing a lot of stuff. And eventually, successful output is going to look like this one. Istio core installed, Istio D installed, ingress gateways, egress gateways, and add-ons. Add-ons contains a Grafana, Prometheus, Yager, and after that, installation complete, it's going to be printed out. So right now, it's halfway through. Okay, seems like going well. Meanwhile, we can see from here on the right-hand side, clear Kubernetes get pod namespace Istio system, and there should be some pods already deployed in Istio system. This is kind of like a kube system, but for Istio's root namespace. So you see Grafana installed, egress gateway, ingress gateway, tracing, Istio D, this is the control plane. Inside this pod, the multiple master components like Pilot, Citadel, and whatnot. And Kiali, Prometheus, all of them are running except Kiali. So it says installation complete on the left terminal, which is good. So how can we verify successful installation? Well, we can analyze and detect potential issues with your Istio configuration using this istioctl analyze all namespaces. So what we're going to do is istioctl analyze -- all namespaces spaces, And this is going to kind of do a verification validation check of all the configurations. Okay, so it printed out two warnings. The namespace is not enabled for Istio injection. Run kubectl label namespace default Istio injection enabled to enable it, or kubectl label namespace default with Istio injection enabled to explicitly mark it as not needing injection. So this is okay because in next section we are going to enable Istio injection using the label per namespace. But anyways, so far two warnings and no errors, so that's okay. It says error analyzers found issues when analyzing all namespaces, but this is not critical. So let's show all the objects by doing a kubectl get pod service in the Istio namespace. So copy this one, paste in, get pod and service in Istio system namespace, and it's gonna print out a lot of stuff. Pods, we've already seen that on our right terminal. So here we have a list of services, and one of the interesting ones to look at is this Istio ingress gateway. Type is of load balancer, and there's already external IP. This is the public DNS of AWS load balancer. If you're using AWS EKS for this demo, you won't see this DNS if you're using like local Kubernetes cluster like Minikube. You're gonna only see local private IP address. So this is good. This is already public load balancer is also created. There are other services like Yager, Kiali, Prometheus, tracing, and whatnot. So it looks all good. So let's move on to the next. We've already covered about service Istio ingress gateway in the Istio system namespace created AWS ELB or type classic load balancer. If you're using AWS EKS, and if you go to ELB console, then you're going to see this load balancer. So we can do that here. From here, EC2. Actually, I have an EC2 console open. So scroll down, click load balancers, and then you're going to see one load balancer at this point. So yes, this DNS got created just right now, August 19, 2020, and type is classic. This is a DNS name, so you can access this one actually, but nothing is really serving in the backend, so nothing happens. And these ports are opened by Istio configuration, so 80, 443, and D3 ports. Security group is also created, Istio. Other than that, nothing else is really enabled. For example, like access log, WAF, nothing is enabled, but load balance is already created. So next section 2.3, we are going to enable Istio sidecar injection by labeling namespace. We need to add a namespace label to instruct Istio to automatically inject Envoy sidecar proxies whenever you deploy your application later. So let's say you're going to deploy deployment or a pod, but as long as you label a namespace, then Istio Envoy proxy is going to be injected automatically whenever you deploy pods. So first, what we're gonna do is to describe default namespace. So copy this command, paste in kubectl describe namespace default, and we are going to say metadata like name default, labels nothing. So what we're gonna do is to add some labels here. So this is the exact same output here. And then next, we are going to use kubectl label namespace default with, we are adding this key value pair label. This is the Istio specific key name called Istio injection, and a value should be enabled if you want to enable it. So label namespace default, key name is Istio injection, equal enabled, enter, right? And then next, we want to verify label is added. So we're gonna do the same thing, previous command, describe namespace default. And now you see labels, Istio injection enabled is added. So this is good. So whenever we deploy some new pods in default namespace, then Envoy sidecar proxy is gonna be added to every single pod in default namespace. So if you want to enable Istio injection on different namespaces, for example like staging or production, then you need to enable each namespaces manually, like this one. And in case you want to disable this namespace, what we're gonna do is Istio injection minus or dash. This is how you're going to disable it. So I'm gonna just demonstrate this one. I just did, and describe namespace as well. Then we see labels gone. So this is how to disable it. So I'm going to enable this back because we are going to use Istio. Describe to verify that labels are added, and this is good. This is all for Istio installation and also enabling Istio sidecar injection. Okay, so in third chapter, we are going to cover monitoring and telemetry. So when installing Istio using demo profile, as I already mentioned in previous chapter, it already installed monitoring tools such as Grafana, Prometheus, Kiali, and Yagar. We will cover a lot more about details about Kiali dashboard and also Yagar in later chapter. But we are going to cover a little bit of a monitoring aspect of it, like Grafana and Kiali, a little bit in this chapter, so that we can see whenever we are going to deploy pods and applications, we can start using these dashboard. So first, we are going to list pods in Istio system. This is already done in a previous chapter, but I'm going to demonstrate it again. So kubectl get pod namespace Istio system, and this is gonna list out all the pods in Istio system, which is a root namespace for Istio. And you see, we've already seen that in a previous chapter, but we see Grafana, egress, ingress, and tracing, Kiali, Prometheus. So what we are going to do is to open up Grafana dashboard as well as a Kiali in this chapter. So section 3.1, check Grafana dashboard. So to open up Grafana dashboard using istio.ctl is pretty easy. So what we're gonna do, create terminal, and then paste in this istio.ctl dashboard in Grafana. Enter. This is gonna open up Grafana dashboard. This is really easy to open up as opposed to kubectl port forward and a localhost, like port number you specify. It's accessing localhost 57090. This is really just creating a port forwarding tunnel from localhost this port to pod running inside the EKS cluster on a remote environment. But again, I'm going to show you how to open up some of the useful dashboards. So what we're going to do is to, on the left hand side here, you see plus icon, and under you see create dashboard folder import. We are going to import templated dashboard that are available in the community, which are also free. So we're going to click import. And then here, grafana.com dashboard. And you see here, paste the grafana.com dashboard URL or ID. So there are some of the community dashboard available, and I already picked up some of the dashboard ID here. So paste 3119 just for example, and click load. And after that, what we need to do, this is gonna be a name. This is already pre-filled in this area, Kubernetes cluster monitoring via Prometheus. Next, what we're gonna do is under this Prometheus, we need to click this drop down, and I need to click Prometheus. This is gonna be a data source. Click Prometheus, and then this green import button is gonna be enabled before it was grayed out. So now click import, and that's it. So this is one of the many dashboards that we can use for free on a Grafana. So here we see cluster memory usage, CPU usage. This is the EC2 instances, CPU, and the memory metrics. And also we have pod CPU usage, container CPU usage, pod memory, container memory. Because we've already deployed pods for like Prometheus and Kiali and Grafana, so they are using this CPU. Also, I'm going to show you another pretty cool dashboards that I like to use. So grab one of these IDs in these links in the bullet points. So I'm going to grab this ID here. Do the same thing. Left hand side, hover your mouse over this plus icon and import. And you can click save dashboard to save current dashboard. Save, okay. And then here paste in this ID, load. Okay, the name is going to be already pre-filled to be Kubernetes cluster detail dashboard. You need to click this drop down to select the Prometheus as a data source and click import. And this is going to be another visualization of Kubernetes cluster monitoring the metrics. So right now here, it's a little bit different rendering and also positioning of those metrics dashboard. So here I have CPU usage, memory usage, file system and storage usage, and the CPU usage in different kind of graph, memory usage, file system, and you can expand these tabs to see pods. You see pods 0 running, all namespace, which is not correct. So some of the dashboards don't work well. So what I'm going to do is, this is definitely not true. This is not correct because we already have pods running. So maybe this is looking at the different namespace, or I don't know what they're doing. So try different dashboard UID. So import, paste this one. This time we're gonna do 8685, load, data source as Prometheus, import. This is also NA, not available. Cluster Prometheus or default, you have two choices in this dropdown. Node O, namespace O. But I believe that this is looking at default namespace because I've used this one before and they had no problem showing a matrix. We're gonna try another matrix called dashboard called 315. Select Prometheus. So let's take a look here. So this time the network I/O is at the top of the dashboard, memory, CPU usage, file storage, and this seems like pretty similar to what we have already seen in the first time. Kubernetes detail dashboard. So, but anyways, I wanted to show you we're gonna use this to kind of visualize what's going on with a Kubernetes cluster and also pods as well. Alright, so that's it for Grafana. Next, we are going to check out k8s dashboard. This is probably the new dashboard because Grafana, you probably have seen this one here using Kubernetes, but k8s, this is part of the Istio installation. This is going to show us a topology of microservice architecture. So we're going to see visualizations of traffic flow with backend services like this one. And it's going to also show us a little bit of metrics like latencies and speed and also percentage of traffic going through. It's kind of the same thing. We are going to use the install Istio CTO dashboard and the k8s. So in this terminal, we were running Istio dashboard Grafana. This is a local port forwarding. So we're going to kill this one by pressing Ctrl C. And now I'm going to paste dashboard k8s, enter. And now we are going to see k8s dashboard for the first time, right? So this time port number is 59201. It's the same thing. It's doing a port forwarding from localhost to a remote cluster in AWS EKS, or it could be GKE, depending on where you're running cluster. So now it's showing us a login page, and username and password is admin by default. So what we're gonna do is to enter admin and admin. Now we are in k8s dashboard. Right now on the left hand side there are two tables with overview. This is the default one. And we see two namespaces. Default, which has 0 applications, and Istio system with a green checkmark icon. We have 7 applications, so I clicked 7 applications, and then we see Grafana, Egress, Ingress, IstioD, Yagar, k8s, Prometheus. All these are deployed in Istio system namespace, and you can see health, labels. Also, if you click on one of these, let's say we click on Grafana, it's going to show us a next dashboard view, and you see traffic, inbound metrics tab, outbound metrics tab, and overview. And if you click on workloads Grafana, now we are here in the workloads on the left hand side, and here we are going to be able to see logs as well. Log with a container called a Grafana, and also Istio proxy. This is a sidecar envoy proxy is a log, and this is a Grafana containers log. It's kind of like Kubernetes dashboard where you can see logs of containers. And we see tabs like inbound, outbound, also traffic. But what's more interesting is click this on the left hand side. We have empty graph because we have nothing installed. But this is the same view. We are going to see applications that are deployed in a cluster. So here we have nothing. Namespace, we can select Istio system and also default. Display, traffic animation, unused nodes, security. We're gonna check almost everything, and we see something showing up here. These are sitting like IstioD, Yagar. We see a lot of components in Istio tracing. k8s. This is a k8s service. Triangle is service, and then square is pod. So how do I know? Click this legend button. It's gonna show us about labeling. So triangle is a service, square is app, which is like a pod. Purple one is virtual service. We haven't really deployed anything, so that's why we don't see any applications other than the ones that are installed by profile, demo profile. So we're gonna stop here because we need to deploy applications to really make use of this k8s dashboard and then see something like this by sending actual traffic to application. But anyways, I wanted to show you that k8s looks like this, and we're gonna use k8s a lot in the coming chapters.